Alright guys, it's Mr. Lynch coming back at you with another great math video. Today we're going to do lesson 7 because I'm gone. So today is no bending or stretching. And again, this is the advanced, doing grade 8 stuff. So lesson 7, no bending or stretching. So the first thing we're going to do is for each question, the unit is represented by a large tick marks on with whole numbers. So find the length of the segment to the nearest eighth of a unit. So I need to find the length of the segment to the nearest 8. So I'm going to zoom in, and it doesn't tell us whether it's inches or centimeters. It's just units. So there's one. Oops. Where's my draw? There we go. There's 1 unit, 2, 3, 4, 4.5. So let's see. We got 1, 2, 3, 4, 5, 6, 7, 8 in a whole. So these are eighths. So we have a half plus an eighth. Now 1/2 plus 1/8. I need to convert this 1/2 to eighths, so that is 4/8 plus 1/8. Well, that's 5/8. Perfect. So this is now 4 and 5/8 for this first one. Now, I'm going to let you guys do 2. And this one, number 3, is a little more fun because we have to think about it. So this is definitely less than 4. 3.5 looks like it's probably about there, which would make this 3 1/4, or 3 3/4, roughly. Now, the way I did that, guys, is I just cut it in half. So what I'm going to do is I'm going to find halfway between 3 and 4, which looks like it's roughly, that's not quite it. Maybe there. That looks like it's about halfway between 3 and 4. And because we're trying to estimate, that's the key thing here, is we're trying to estimate the length to the nearest eighth. So that was about halfway. So I'm going to go halfway again, which looks like there. So I've done half, then half. So that's a quarter. So it looks like 3 3/4. Perfect. I'm going to leave you guys to do 2 and 4. Now the second part, sides and angles. So we're going to translate A so that P goes to Q. Okay, that's not bad. So we're sliding everything this way, that far. Actually, that's a little too far. We're sliding everything this way, that far. So if I'm translating, I know this point, I'm going to mark off all my big points I need to mark on here. These are all the big points. Perfect. So now I'm going to move them all that far, which is 1, 2, 3, 4, 5. So this point, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. Now I can draw this in. So where is my ruler at? Nope, not what I want. That's ink to shape. Where is my ruler? Nope, not what I want. Where'd the ruler go? It's fine. I'll just do a straight line. What was that? That's not what I wanted. I just want a straight line. Not helping. So, you know what? I'm just going to draw it in there. It's fine. It's whatever. It works. It'll be close enough. I don't know why I don't have a ruler. I thought I did. So there's our shape translated so that P goes to Q. Now we're going to write the length of each side in grid units. So this is a 1, 1, 4, 2, 3, 1, 2, 2. Perfect. Now we're going to rotate this 90 degrees. So here they give us the isometric grid. Okay, this is a grid that, remember, uses 60 degrees. But if we look, this is a 90-degree angle to this line right here. Oops. To this line right here. So I know I'm going to be using that line. That's so weird. Why don't I have my ruler? I don't want to use sticky notes. That's really weird. I don't know. I'll find it later. Anyways. So with this, we're going to rotate it 90 degrees. So what that means is that I'm going to basically orient it, and it's clockwise. So we're going, oh my gosh, this way. So this point is going down here. Okay, not bad. It is going to be a little bit tough to do this because this right here is going not on the baseline, so it's going to be a little bit farther than 1, 2, 3, 4. So I'm going to go 4 away, so 1, 2, 3, 4, and a little more. Looks like it should be about there. Did I go way more than 4? 1, 2, 3, 4, and a little more. Perfect. All right, so I'm actually going to draw this in blue. Does that look about the same length? That looks way too long. What is going on here? Oops, I don't want to change that. So this right here is 1, 2, 3, 4. So this has to be less than 4. Okay, that works. I don't know what I was thinking. Oh, I see what I messed up. So guys, what I was messing up was I was thinking that this would be longer than this, but it's not. It's a little bit shorter actually. So I'm gonna go probably to here. Does that look right? Let's see if that looks right. I'm gonna measure. That looks about right, yep. And then this 2 is gonna go up to about here. That looks about right. And actually, I know exactly where it should go. It should go right here, which would make this a 30-degree angle and this a 60-degree angle. Perfect. So this right here is 60 degrees. This right here is 30 degrees, and this is another 90-degree angle. Perfect. We have all our angles set exactly where they should be, and this looks to be about the right size. And again, in the image, write the measure of each angle. The image is what comes after, right? It's what comes after the transformation is done. Now we're going to reflect. I'm going to let you guys reflect. I'm going to reflect 1 point, maybe 2. We're going to reflect the pentagon across the line L. And in the image, we're going to write the length of each side, and we may need to make our own ruler with tracing paper. So in the image, We're also going to write the measure of each angle in the interior. So I'm going to actually reflect this point right here. So that's 1, 2, 3, 4 from the line. So I'm going to go 1, 2, 3, 4 from the line. Oh, what am I saying? That's not... Wow, they're really, really trying to trick us here. That's not 4, that's 1, 2, 3, and a third. So 1, 2, 3, and a third should go right there. You guys got to be careful. I wasn't being careful. You guys are supposed to catch this. And 1 right there, so we're going to go 1 away. So I'm actually going to label these points so I know I did it right. So that's A, I'll call that B, C, D, and E. This is D prime, and that's A prime. So far, that looks pretty right. I'm going to let you guys finish reflecting. Here is a grid showing triangle ABC and 2 other triangles. So we can use a rigid transformation to take ABC to one of the other triangles. So let me just outline ABC. Oops, I didn't mean to erase. Now a rigid transformation, that's something we haven't heard yet. Now, rigid, all right, this is a really key thing. We've heard of transformations, translate, rotate, reflect, dilate, things like that. But a rigid transformation is a transformation that keeps size the same. So it keeps size the same. Now we have to use a rigid transformation. So a transformation that keeps our sizes the same are the sizes going to stay the same going from ABC to this triangle here, or going to this triangle here? I'm going to let you guys be the judges of that. And you need to explain how you know and what transformation you're going to use to get there. And I expect you guys to do this. Are you ready for more? You guys are more than ready for this. All right, you guys can do anything. So, rigid transformations. A rigid transformation is a transformation or a move that doesn't change measurements on any figure. So all of our measurements are exactly the same. Now, earlier, we learned that a figure and its image have corresponding points. With a rigid transformation, figures like polygons also have corresponding sides and corresponding angles. These corresponding points have the same measurements. So no matter what we do, they will have the same measurement. All right, so EFD was reflected to make ABC across a horizontal line, then translated. Corresponding sides had the same length, so 2.83, 2.83. Then we have, wow, that was bad, 2.24, 2.24. Then we have 3.0, 3.0. And the angles are going to follow that same thing as well. Alright guys, so that's it for this video. I'll see you guys tomorrow, and we'll go over some of this stuff, and we'll move on to the next lesson. As always, guys, make sure you like, make sure you subscribe, make sure you are ringing that notification bell so you guys can see these videos as soon as they come out. We'll see you next time.